Okay, so I just got this question. Would 101 work as the direction vector parallel to the x-axis? And so let's think about this for just a second. What I'm going to do is I'm going to find this point. So this has gone 1 unit in the x, 0 units in the y, and then 1 unit in the z. So here is, can you see my nice little, there's that point. Okay, so if you're graphing the point 1, 0, 1, you've gone 1 unit in the x, this is the x, this is the y, and this is z. You've gone 1 unit in the x, you've gone 1 unit in the z, but you didn't go at all in the y direction. Notice how that, I didn't come out and make that, so it's a prism with a kind of a depth here of 0. So it's a nice little rectangle is what I was trying to draw. Okay, so if this is that vector, that means you're going from the origin to that point. Okay, so if you notice, what we're doing is we're starting, we've gone in that direction, we've gone 1 unit in the x, we've gone 0 units in the y, and 1 unit in the z. So we started at the origin 0, 0, 0, and we've gone to this point. And so the question is that parallel to the x-axis? The answer is no. Parallel to the x-axis, parallel to the x-axis means that you're doing something like this. Okay, so these sorts of things here. So you have moved 1 unit in the x direction. Okay, let me think through this. You start at the origin and you've come here. On this one, you didn't, but this vector is not nailed down. Okay, that's what we need to say. Like this vector right here is the same. It moved a certain amount in the x direction, but it didn't move in the y and it didn't move in the z. Okay, so if you keep in mind, vectors aren't nailed down in space. So this one may have gone from the point, this point right here would be the point 0, 1, 0, because it went up 1 unit in the y direction. I lied, my bad. Okay, it's x is 0, its y is 0, its z went up 1. And then, so say it came out here to this point. Well, this point has gone 1 in the x, 0 in the y. Notice it didn't move anyway, and then 1 in the z. So when you subtract this, if this is if you want the vector a, b, then we take point b, subtract away a, and I have 1 minus 0 is 1, 0 minus 0 is 0, 1 minus 0, I lied, 1 minus 1 is 0. So this becomes that vector because vectors aren't nailed down in space. So this vector, it's easy to see that it's gone from the origin to this point 1, 0, 0, so therefore it's the vector 1, 0, 0. But if I think of it up here being parallel to that, what it's done is it's gone from this point to that point. When we subtract, we get this same vector. Okay, so the way that I think about it is that a vector lines, we have to give them a position vector so that we know where exactly, like if I've got a line in space somewhere, here's the origin, I have to say, okay, first get to the line and then travel up and down it, because this one right here is not nailed down to a particular spot in space. So same idea here. This is a long way to say no. Would 1, 0, 1 work as the direction vector parallel to the x-axis? No, it needs to just be 1, 0, 0, or any multiple of that would be parallel to the x-axis. Hopefully that helps. Let me know if you have further questions.